the sky. And what we're doing is shooting laser beams into the sky, and if you were here on a night that it wasn't snowing, that would go all the way to the edge of space. We would get echoes from the ground to 100 kilometers. And so I'm going to light the cigarette looking lame because I don't smoke. Only if it's in the interest of science. And Andy, if you can, yeah, turn off the light. So this is actually a simulation of what we do when we use lasers to reach into things like forest fires. We use lasers to reach into volcano clouds that are crossing the range. The laser light that you see actually echoes from the air itself, which is invisible, as we think of it, even though, except the fact the sky is blue, so you know it's not truly invisible. And then you get enhanced echoes from aerosols, in this case, obviously, smoke. So that is essentially what we're doing with LIDAR. We're launching, if you will, optical weather balloons. Every time the laser fires, we get an echo from the atmosphere that either tells us exactly where a dust layer is. We've done this for civil aviation, for the volcano observatory at the university, where they wanted to track ash clouds and validate their ash tracking. We do it routinely here on a night. This is a night where we would never come to Poker Flat to take measurements. We'd be quietly at home enjoying the fact it was snowing. But on clear nights in a rocket launch period, what we do is we come out here in that sunset, we turn the LIDAR on, the actual laser light coming back from the atmosphere can be turned into a temperature profile, just like a weather balloon, measuring the temperature.
Very cool.
And so what we're doing essentially is launching weather balloons to the edge of space through the whole night that a rocket might launch at midnight and make a very precise physical measurement, and we can then give a meteorological context to that measurement through the whole night. So for example, 2 years ago for the MTEX launch, we launched turbulence measurements on a rocket that made measurements around midnight, 2 launches for about in a period of an hour. But now we have the whole context to study that from the LIDAR data from the whole night to say, what does that turbulence represent? What kind of weather in the upper atmosphere does that turbulence represent? Possibly what kind of climate significance does that turbulence and weather have? So that's what essentially we do. The building is designed, we have large